Okay, so we're going to be changing things around here a little bit now, because this time we're told that the university professor determines that no more than 80% of this year's history candidates should pass the final examination, and he tells us that they're normally distributed, and he gives us the mean and standard deviation. So find the lowest score necessary to pass the examination. Now he says no more than 80% pass, so we split it into an 80-20 split, or a 20-80, whatever way you want to look at it. Okay, so obviously if 80% are passing, that's most of the people. Okay, so I'm going to split my curve, okay, here, and what I'm going to do is I'm going to say obviously that this is the pass mark here, corresponding here. Okay, so 20% are not going to reach the pass mark, and then we have this 80% up here that do. Okay, so I'll put the 80% here in red, because this is what I want, and then in blue here I have this 20% who don't. Now if we look at this here, we can clearly see we've hit a problem, because what we're trying to solve is the probability of a Z score which is greater than K and giving out a probability of 0.8%. Okay, now we can't do that because we just realized, even from looking at the picture or realizing that we wanted greater than 80%, meaning that our tables book, it's in the negative Z scores, which we won't be able to handle. So if we mirror image this, and again then we'll split it. So this time we'll split it, and this time our 80 now, still an 80-20 split. So now our 80% is to the left, and our 20% is to the right. Okay, so what we're going to do instead is we're going to find the probability of Z less than K, which actually gives us 0.80. So that corresponds to this diagram here. Okay, so this is going to give us out a positive K value. So we go to our tables book and we look up a K. Now when we look this up, the closest we actually see in the tables book is, the closest value is 0.7995 is the closest to this that I actually see, and that corresponds to a Z score of 0.84. Okay, now remember that's our K that we need there. Now for us though, that was for less than K, so this implies then we're looking for the probability of Z greater than K to give out a probability of 0.80, which is this graph here, which means we need the actual negative Z score, which implies that K for us is minus 0.84. Now we have to convert this into a score. Okay, so we use our standardizing formula again, which is x minus mu over z over sigma, but this time we don't know the x, we know the 62 is our mean, and we know our sigma to be 13, and we know that that gives out a score of minus 0.84. Okay, so then that will tell us that x minus 62 equals 13 times 0.8 minus 0.84 plus that 62. So this implies that gives us an x which is equal to 51.08. Okay, so the minimum mark to pass, x will need to be 52% in order to pass this exam. Okay, because only 80% of students are allowed pass.